as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2. The important short question is: 1. Define ANOVA. Answer. ANOVA stands for Analysis of Variance. It is a statistical method used to compare the means, averages, of 3 or more groups to find out if there is a significant difference between them. It tells us whether the difference in results is real or just happened by chance. Example. Suppose a teacher wants to check which teaching method is better. She uses 3 methods on 3 groups of students. Group A, traditional method. Group B, online method. Group C, video lessons. After the exam, ANOVA helps compare the average marks of all 3 groups to see if any method gives better results than the others. Easy trick to remember. A.N.O.V.A is equal to averages not 1, verify all. Use ANOVA when you want to compare 3 or more groups at once, instead of comparing them 2 at a time. Next important short question is: 2. What is report writing? Answer. Report writing is the process of presenting information in a clear and organized way. It's often used to explain findings, research, or any topic in a formal, structured manner. A report includes facts, details, and conclusions, usually supported by data or evidence. Example. If you conducted a study on the impact of online education, your report would include: 1. Introduction, what you studied and why. 2. Methodology, how you did the research, surveys, interviews. 3. Results, what you found from the data. 4. Conclusion, what you learned from the study, example, online education is effective for students. Easy trick to remember. REPORT is equal to reason, explain, present, organize, results, tell. Report writing is a clear, logical way to share your findings with others. Next unit 2 important long questions. First important long question is: 1. Distinguish between parametric test and non-parametric test. Answer. Parametric tests and non-parametric tests are 2 types of statistical tests used in research. They help researchers analyze data, but they are used in different situations depending on the nature of the data. 1. Parametric tests. Definition. Parametric tests are statistical tests that assume the data follows a certain distribution, usually a normal distribution. They require the data to meet certain conditions like homogeneity of variance and a known mean. Characteristics. Assumes normal distribution, bell curve. Used for interval or ratio data, example, test scores, heights. More powerful if data meets assumptions. Example tests, t-test, ANOVA, analysis of variance. When to use. When your data is normally distributed and you can calculate a mean, average. For example, if you want to compare the average marks of students from 2 different classes, you'd use a t-test. 2. Non-parametric tests. Definition. Non-parametric tests do not assume that the data follows any specific distribution. They are used when the data doesn't meet the assumptions required for parametric tests. Characteristics. Does not assume normal distribution. Used for ordinal or nominal data, example, rankings, categories. Less powerful than parametric tests but more flexible. Example tests, Gsquare Test, Mann-Whitney U test, Kruskal-Wallis test. When to use. When your data is not normally distributed or you have data in categories or ranks. For example, If you want to compare preferences of students for 3 different teaching methods, rankings, you'd use a Kruskal-Wallis test. Key differences. Aspect parametric test, non-parametric test. Assumption assumes normal distribution, does not assume any specific distribution. Type of data, interval ratio data, example, test scores, weight, ordinal nominal data, example, rankings, categories. Examples, t-test, ANOVA, Gsquare Test, Mann-Whitney U test. Power, more powerful when assumptions are met, less powerful but more flexible. Easy trick to remember. Parametric is equal to precise assumptions, powerful results. Non-parametric is equal to no assumptions, not as powerful. This way, you can easily decide which test to use based on your data type and distribution. Next important long question is: to explain t-test and f-test. Answer. The t-test and f-test are two statistical tests used to compare data and help determine whether the differences between groups are significant or due to chance. Let's break them down. 1. T-test. Definition. A t-test is used to compare the means, average, of two groups to see if they are significantly different from each other. It's called a t-test because it uses the t-distribution to calculate the significance. Types of t-tests. One sample t-test compares the mean of a sample to a known value, example, the national average. Independent t-test compares the means of two independent groups, example, the average test scores of male and female students. Paired t-test compares the means from the same group at different times, example, scores before and after training. Example. You want to check if a new teaching method improves student performance. You compare the average marks of students before and after using the new method. If the difference is significant, the new method works. 2. F-test. Definition. An F-test compares the variances of two or more groups. It's used to check if the variability, spread or differences within a group between the groups is significantly different. Example uses of F-test. ANOVA, analysis of variance, uses an F-test to compare the means of more than two groups. Comparing variability, comparing the performance of two different classes to see if the variation in scores is significantly different. Formula. The F-test calculates the ratio of variances. F is equal to variance of group 1 variance of group 2. Example. You want to know if the variation in exam scores is higher in one class than in another. The F-test helps you compare how spread out the scores are. Key differences. Aspect t-test, F-test. Purpose: compare means of two groups, compare variances between groups. Data type: interval or ratio data used for comparing variances, often with ANOVA. Example: compare average test scores between two groups, compare test score variation in two classes. Easy trick to remember. T-test is equal to 2 means, T for 2. F-test is equal to F for variance, F for flexibility in comparing variability. These tests help researchers draw conclusions and make informed decisions based on data. Next important long question is: 3. Explain briefly the utility, conditions, and limitations of applying Gsquare test in research. Q3. Explain briefly the utility, conditions, and limitations of applying Gsquare test in research. Answer. The Gsquare test is a statistical test used to determine whether there is a significant relationship between two categorical variables, variables that can be divided into categories like male, female, yes, no, etc. It helps researchers understand if the frequency of an event is different from what was expected. 1. Utility of Gsquare test. The Gsquare test is useful in various research scenarios. Testing independence to see if two categorical variables are independent of each other. Example, checking if gender, male-female, is independent of preferred study method, online traditional. Goodness of fit to test if the observed data matches the expected data. Example, checking if the distribution of students in different faculties matches the expected distribution. 2 conditions for applying the Gsquare test. For a Gsquare test to be valid, the following conditions must be met. Data should be categorical, example, yes, no, male, female, colors. Observations should be independent, meaning one observation doesn't influence another. Expected frequency in each category should be at least 5. If it's less, the Gsquare test may not be reliable. 3 limitations of Gsquare test. While the Gsquare test is useful, it has some limitations. Not for small sample sizes, the test requires a minimum sample size to be reliable. Small samples can lead to inaccurate results. Example, if there are too few students in each category, the Gsquare value might not be meaningful. Requires large categories. The Gsquare test cannot be used with data that has many categories with very small frequencies. Cannot show the direction of the relationship. It only tells you if a relationship exists but doesn't explain how or why. Easy trick to remember. CHI is equal to categorical, independent, expected frequencies. Utility helps test independence and goodness of fit. Conditions, categorical data, independence, expected frequency 5. Limitations, small samples, too many small categories, no direction of relationship. The Gsquare test is a powerful tool when used correctly but requires careful application to get meaningful results. Next important long question is: 4. Briefly explain the process of conducting one-way and two-way ANOVA. Answer. ANOVA, analysis of variance, is a statistical method used to compare the means of multiple groups to determine if there are any statistically significant differences between them. 1. One-way ANOVA. Definition. A one-way ANOVA is used to compare the means of 3 or more groups based on one independent variable. Process. Step 1. Define the groups. Choose one factor, independent variable, that you want to study and divide your data into different groups based on that factor. Example, you want to check if 3 teaching methods, traditional, online, and hybrid, affect student performance differently. Step 2. Hypothesis testing. Null hypothesis, H. There is no difference in the means of the groups. Alternative hypothesis, H. There is a significant difference in the means of the groups. Step 3. Collect data and perform ANOVA. Collect data for all groups, example, students' marks, and perform the ANOVA test to calculate the F statistic and p-value. Step 4. Interpret results. If the p-value is less than 0.05, you reject the null hypothesis, meaning there is a significant difference between the groups. 2. Two-way ANOVA. Definition. A two-way ANOVA is used when there are 2 independent variables and you want to check their effect on a dependent variable. Process. Step 1. Define the factors. Choose 2 factors, independent variables. For example, you want to check the effect of both teaching methods and student gender on performance. Example, factors is equal to teaching method, traditional, online, and gender, male, female. Step 2. Hypothesis testing. Main effects, check the effect of each factor separately, teaching method and gender. Interaction effect, check if there is any interaction between the 2 factors. Step 3. collect data and perform ANOVA. Gather data for all combinations of factors, example, male students in online method, female students in traditional method, and perform the two-way ANOVA. Step 4. Interpret results. Look at main effects and interaction effects. If the p-value for any effect is less than 0.05, it indicates a significant relationship. Easy trick to remember. One-way ANOVA is equal to one factor, multiple groups. Two-way ANOVA is equal to two factors, main and interaction effects. Both one-way and two-way ANOVA are used to determine if the differences between group means are statistically significant and help researchers understand the effect of multiple variables. Next important long question is 5. Write the contents of a research report. Answer. A research report is a structured document that presents your research work in a clear, organized manner. It allows others to understand your study and findings. Here are the key contents of a research report. 1. Title page. This is the first page of your report and contains title of the study, brief and specific. Name of the researcher, your name. Institution, university name, where you conducted the study. Date of submission, when the report is submitted. 2. Abstract. A short summary, about 150 to 250 words, of your research. It includes the research problem, methodology used, key findings, conclusion. Example, this study examines the impact of online education on students' academic performance. The research shows that online education has a positive effect on students' learning outcomes. 3. Introduction. The introduction introduces the research problem and its context. It includes background information, statement of the problem, objectives of the study, research questions, significance of the study. 4. Literature review. A review of previous research related to your topic. This section highlights key studies and findings, gaps in existing research. Example, previous studies have shown mixed results about the effectiveness of online learning. 5. Research methodology. This section explains how you conducted the research, including research design, survey, experiment, case study, data collection methods, questionnaire, interview, etc. Sampling techniques, data analysis methods. 6. Results and discussion. This is where you present your findings. Data presentation, tables, graphs, charts. Interpretation of the results. Example, the results show that students using online education had 15% better scores. 7. Conclusion. Summarize your key findings and their implications. Suggest areas for further research. 8. References. List all the sources you used to support your research in the required citation style, example, APA, MLA. 9. Appendices. Include any additional material like survey questionnaires, interviews, or extra data. Easy trick to remember. TAILRRCA. Title, abstract, introduction, literature review, research methodology, results, conclusion, appendices. A research report is a clear roadmap that guides readers through your study from start to finish. Follow this structure to make your research easy to understand. I hope you understand easily each question. All the best, students, for your upcoming exam. For other subject quick revision. Important questions. Previous question papers. And syllabus. Links are available in description. Check out once. Thank you for watching. Like and share this video with your friends.